Hello, this is John from caveofprogramming.com, and this is a tutorial on how to choose which Java collection to use for a particular purpose. So I was going to make in this tutorial a video on complex data types made of multiple collections, but I'm going to save that for the next tutorial, and that will then be a sort of worked example of this, because actually one of the most common questions that you face in the context of using collections is, how do I choose which collection class to use? And that's a question that comes up a lot in one form or another in exams, and interviewers on job interviews ask it a lot as well. And of course it's the first thing you need to know when you're going to use a collection. Which one should I use? We've already covered the particular details of each collection, but I just want to kind of make a summary and just a quick guide to how to choose between the major types in this tutorial. And I'm going to depart a little bit from my usual format. I'm not going to type this as I speak, as I usually do, because I recorded this video like 4 times now and I kept missing stuff out, and also the typing the comments just took absolutely ages. So I'm just going to talk through this stuff rather than type it as I go. So the first thing you need to consider is, do you want a list, a set, or a map? Those are the 3 main groupings of collections in Java. And lists, they store lists of objects, and it's really quite intuitive. It's a bit like a shopping list. If you think of a shopping list, it's kind of like that. And duplicates are allowed in lists. You can have the same item written down twice, just like you can in a shopping list if you want. The objects remain in the order that you add them in the list, unless of course you sort the list, because you can sort a list, but you have to explicitly sort it. The objects will not be sorted as you add them. You have to sort it later. So the objects are just kept in the order that you add them in, as with a shopping list. And the elements in a list are indexed via an integer, and what that means is, it's just like writing down a list and writing 1, 2, 3, 4. Or in this case 0, 1, 2, 3 and so on. So you have a particular number for each item in the list. If you want to check for a particular item in the list, like you want to know, does this item exist in this list, that's pretty slow, because again, as with a shopping list, to find a particular item you've got to go down the list, check each item. If you're looking for oranges, let's say, you have to check each item, and eventually you either get to the end of the list and either you've found that oranges is in the list, or else you've got to the end and it wasn't in the list anywhere. So it's pretty slow business to check if a list contains a particular item. On the other hand, looking up an item by the index is fast, in the same way that with a shopping list, if you've numbered it, which would be a bit crazy for a shopping list, but let's suppose you have, going to item number 15, let's say, is going to be pretty fast, because you just look down the list of numbers and it's really quick. And iterating through lists is fast as well. They are designed to be iterated through to traverse the list, in other words, to get one item after the other in order. It's a pretty fast procedure, as fast as it can be. And yeah, of course, remember that you can sort a list if you want to. So the bottom line is, you want a list if you just need to store a list of objects. You don't need to remove duplicates, and you just want those objects to remain in order, in the order that you add them. And there are various subtypes of collections, of course, and we'll get into that in a minute. But now let's take a look at when you might want to use a set. And the bottom line is, you probably want to use a set if you need to remove duplicates. That's probably the most common reason for using a set, because sets only store unique values, and that makes them good for removing duplicates. If you keep trying to add the same item again, you only end up with one of those items in your list. They're not indexed, unlike lists, so there's no particular position in the list that each item has, or at least you can't say, I want item 15 and get it quickly. On the other hand, and another very good reason for using a set rather than a list is that sets are optimized for finding particular objects in the list. So if you want to know, is oranges in this list, you can find out very quickly. And by the way, I just use strings in my collections here, but of course you can use objects of any type in your collections. Now with sets, if you want to add objects of a class that you created yourself, you need to remember that the objects in a class must implement the hashcode and equals methods, and you can get your IDE, as we've seen before, to implement those methods very quickly for you. But they've got to have those methods so that the set is able to know if two objects are the same object or not. You tell it, you decide whether objects are the same or not by implementing hashcode and equals. So that's lists. Lists are good for just lists of things. Sets are great if you want to remove duplicates or you want to very quickly check for a particular object. And if you want key value pairs, then you'll need to use a map. A map stores key value pairs. So a map is a lot like a lookup table. It kind of is a lookup table where you have a particular key, which could be an integer or a string or whatever you like, and you use that key to retrieve another object, basically. And maps are optimized so that retrieving a value by key is fast. If the key is an integer and you're only going to have consecutive integers, then you probably want to use a list. But if you haven't got an integer key, or the integers are just all over the place, they're not a consecutive list, then you'd use a map. And maps are designed so that getting a value, getting one of your objects out using the key, is as fast as it can be. Although it's never going to be lightning fast to do that. And if you've got to iterate through something a lot of times, then you probably want to try avoid using a map. Like you probably don't use a map to store the objects in a game, or probably not, I suppose. You probably want to try to use a list or a set or something. Iterating over maps is slow. Actually, that's not quite true. Iterating over map values is very slow. Try not to do that. But iterating over the keys is it's reasonably fast. But you don't really want to do it. So like, if you can avoid it, don't do it. Maps are not optimized for iteration, let's say. Iterating through all the values in a map is not a terribly fast process. So if you've got something and you want to iterate through it a lot as quickly as possible, try to use a list or a set or something. And if you do have to iterate through a map, at least iterate through the keys. Don't try to iterate through the values, because that's a horrendously slow business, however you do it. And again, if you want to use your own objects as keys, and this doesn't apply to values, but the keys must implement the hashcode and equals methods. So we've got lists, sets and maps. Lists, just plain lists of things indexed by integers. Sets remove duplicates and are optimized for looking things up quickly. And maps store key value pairs, so the keys are a lot like a set, basically. And you can look things up by key very quickly in a map. Maps are like lookup tables. And those are the three basic types. And within those you've got subtypes. So the most common list to use is the array list. That's the kind of default thing to use. And the array list is only good if you want to add or remove things at the end of the list. And if you want to add or remove items anywhere else in the list, use a linked list. And we've covered the details of this in a previous tutorial, so I won't go over it again. But just remember that if you're adding or removing anywhere other than the end of the list, then use linked list, don't use array list. With sets, there are three main types to choose from. Hash set is the default one, but hash set is not ordered. It stores things in no particular order, and the order is subject to changing seemingly at random. So if you need a sorted map, then use tree set or linked hash set. And tree set sorts things in natural order, like 1, 2, 3, alphabetical order or whatever. And you define natural order on your custom objects using the comparable interface. So you must implement comparable for your own objects, comparable for custom objects, custom types, let's say. But if you're using strings or integers, they already implement comparable or doubles or something like that, so you don't have to worry about it. So tree set stores things in natural order, and linked hash set stores things in the order that you add them in initially. So if you want the set just to remember the order that you add them in for the purposes of iteration and traversal, then use a linked hash set. And the reason for these names is that tree set internally uses a tree to sort the sets, a tree structure, which you may be familiar with or maybe not, whereas linked hash set uses a linked list internally to maintain an order in the items. So its linked list effectively links all the items one to the other so that you can traverse all the links, whereas tree is using a tree algorithm to sort them in natural order. And we see the same thing with the maps. 3 main types, and the most lightweight type is the hash map. So by default you usually use the hash map, but if you want to store the keys of the map, and we're just talking about the keys, not the values, in natural order, alphabetical order or numerical order or whatever, then you need to use tree map. And if you use your own kind of custom types in there, then you must implement comparable so that the map knows how to compare them and how to figure out if one item should be later in the list than the other. Whoops, I didn't mean to put that there actually. That should be here on tree map. And for linked hash map, again, that maintains internally a linked list to keep the items in order. So linked hash map just keeps things in the order that you added them to the map in the first place. And notice that there's also a sorted set and sorted map interfaces that you can use if you want, if you're using a sorted map or a sorted set, but of course you don't need to use those. And people always ask why use the interface here and the actual type here, and I like to think of that as being a bit like, it's kind of like when you choose a bank, when you use a bank, all banks have an interface which is similar. They have the same kind of facilities, and once you've chosen the bank, you don't worry about the particular bank anymore. You just deal with the interface. You just deal with the facilities, the cash machines, the counter services and so on. But when you first choose the bank, you have to worry about the particular bank that you're using, the implementation of that interface. And it's the same with sets. You can just use a set, you can use an interface, and deal with the particular, not sets, collections. You can just use an interface and deal with the collection through that interface. And it's only when you first do new that you have to carefully choose the particular implementation of that interface, and later on you just sort of deal with the interface itself and not the class that implements it. So that's kind of a rationale for it. You can kind of forget that you use tree set later on and just deal with the common methods that you have in any set later on. So that's kind of the thinking behind it, but you could use like hash map here, for example, instead of using the interface. It would work just fine. Okay, so that's enough for this tutorial, and in the next tutorial we're going to move on to probably looking at complex data types, where you use 2 or more collections together to hold some data. And you can find this code on caveofprogramming.com, and there are also courses on there on Swing, Android, Java web programming and multi-threading, stuff like that. And my paid courses always have free videos, and there are also some free courses on there as well. So that's it for this tutorial. Do join me again next time, and until next time, happy coding.